All right, let's dive into the story of a single tiny molecule that honestly runs the whole show inside your head. It's the chemical that fuels our drive, our desires, even our ability to get up and dance. This, right here, is the biography of dopamine.
I mean, just think about your day for a second. What was it that pushed you to grab that first cup of coffee? Or to finally tackle that big project at work? Or even something as simple as just getting up and walking across the room? Well, the answer to all of those questions is the exact same powerful little chemical. So, to really get a handle on what dopamine does, we first have to understand the world it lives in. Your brain. Imagine it's like a massive, bustling city with billions of neurons. And they are all talking to each other all the time through this vast, incredibly complex communication network.
So how do they talk? Well, they use chemical messengers called neurotransmitters. And honestly, the easiest way to think of them is like little text messages being sent between your brain cells. They get fired across this tiny, tiny gap called a synapse, and they carry a very specific instruction for the cell that's listening on the other side.
Okay, but not all of these brain texts are created equal. They basically fall into two main camps. On one side, you've got your small molecule neurotransmitters. We can call them the sprinters. They're built for speed, for quick, direct messages. And on the other side, you've got the neuropeptides, the marathon runners. They're bigger, they're slower, and their effects are way more broad and long-lasting, kind of like a company newsletter versus an urgent text. And our hero, dopamine? Oh, it's a total sprinter.
So let's zoom in even closer. Because inside that group of sprinters, there's a really special family of messengers we need to meet.
Right. So inside that sprinter category, you've got this incredibly powerful family called the biogenic amines. These are the molecules that are fine-tuning our entire daily experience, our mood, our focus, our alertness, you name it. And because they have so much influence, it makes total sense that when they get out of balance, it can lead to a whole host of psychiatric disorders.
And if we go one level deeper, inside that family, we find the famous trio, the catecholamines. This group includes our guy dopamine, but also norepinephrine and epinephrine. You probably know that one as adrenaline. You can think of them as chemical siblings. They're all built around this core catechol structure you see here. They all come from the same family recipe.
And that recipe is basically a four-step process. It all starts with tyrosine, which is an amino acid you get from food. Then a really important enzyme turns it into something called dopa. Now this step right here, this is the bottleneck of the whole operation. The speed of this enzyme controls the entire supply chain, which is the brain's clever way of keeping this powerful chemical in check. After that, it's pretty simple. Another enzyme swoops in and bang, you've got dopamine. But what's really cool is that dopamine isn't always the final product. It's often the raw material the brain then uses to build its siblings, norepinephrine and epinephrine.
Okay, so our dopamine molecule has been made. It's been born. But now what? What does it actually do? Let's follow it on a typical day on the job. First things first, as soon as dopamine is created, it gets carefully packaged up into these tiny little bubbles called synaptic vesicles. You can see them here. They're the little red spheres, all loaded up and waiting right at the edge of the neuron, just ready for action. And there's a special transporter called VMAT that acts like a packaging machine, literally stuffing the dopamine inside.
You know, this whole process is just this beautifully efficient cycle. The dopamine gets packaged, then it gets released to send its message. But what happens next is absolutely key. The brain does not like to be wasteful. There's a special transporter, this one's called DAT, that acts like a tiny vacuum cleaner. It just swoops in and sucks all the leftover dopamine back up to be used again. It's this precise, self-regulating system that's designed to send a clean, clear signal every single time.
So we know how it's made, we know how it gets around, but what is the message it's actually delivering? This, right here, is where dopamine really earns its celebrity status. It has two main blockbuster jobs in the brain.
Job number one is movement. Simple as that. There is a major dopamine highway that starts deep in the brain in this area called the substantia nigra. From there, it sends a steady stream of dopamine out to the striatum, and this specific pathway, this is what allows us to start and control smooth, voluntary movements. Every single step you take, every gesture you make, it's all being fine-tuned by this one circuit.
Now, for dopamine's second and, probably its most famous role, motivation. There's another pathway starting right next door in the ventral tegmental area, or VTA for short, that forms the absolute core of the brain's reward circuit. This is the system that says, hey, that felt really good, let's do that again. It's what drives us to seek out pretty much everything we need and enjoy in life, from food to friendship.
So if you want to boil it all down, it's this. Dopamine is the molecule for doing things, and it's the molecule for wanting to do things. It is the absolutely critical link that connects our actions to our sense of reward.
But here's the thing. This beautifully balanced system is also incredibly fragile. And when it breaks, well, the consequences for both our physical and our mental health can be absolutely profound.
Remember that movement highway we talked about, the one that starts in the substantia nigra? Well, in Parkinson's disease, those exact dopamine-producing neurons tragically begin to die off. And without enough dopamine to keep that motor circuit running smoothly, the brain starts to lose its ability to coordinate movement. This is exactly what leads to the tremors, the rigidity, and the difficulty moving that define the disease.
And what is just staggering and frankly kind of heartbreaking is how long the brain can compensate for this. It isn't until 60 to 80% of these specific cells are already gone that the physical symptoms of Parkinson's even begin to appear. It's a testament to the brain's resilience right up until it hits a catastrophic tipping.
Okay, so that's what happens when there's too little dopamine. But what about when there's way too much? To understand that, let's go back to our little vacuum cleaner, the dopamine transporter, or DAT. Remember, its only job is to clean up any excess dopamine from the synapse to end the signal cleanly.
Well, a drug like cocaine comes in, and it completely hijacks this precise system. It physically blocks that DAT vacuum cleaner. It's like putting a big piece of duct tape over the nozzle. So dopamine gets released like normal, but with the cleanup crew totally offline, it can't get removed. It just floods the synapse, hammering the receptors on the next neuron over and over and over again, creating this massive, artificial, and intense high.
And that mechanism right there, that is precisely why these drugs are so unbelievably addictive. They completely short-circuit the brain's natural reward system. They create a chemical signal for wanting that is just so much stronger than anything that natural rewards, like food or social connection, could ever produce.
So when you put it all together, what's the core story of dopamine? It's really a molecule with a dual identity. On one hand, it is the master regulator of our movement. On the other, it's the key driver of our motivation and reward. Keeping that system in a delicate balance is absolutely critical for our health, and it's exactly why this one system is a target for both life-saving medicines and, sadly, for life-altering drugs of abuse.
And I want to leave you with this one final thought. We just spent all this time unpacking the biography of one single molecule. But your brain uses over 100 of these different chemical messengers. So if dopamine's story is this complex and this fascinating, just imagine the incredible stories all the others are telling inside your head right this very second.